versus orbital period. So as you can think about, this is Earth, 1 year and 1 Earth mass. And this is Venus. Venus is very similar to Earth. And this is Jupiter, 10-year, 20, 12-year period. And this is the Saturn. Saturn is a little bit smaller than Jupiter in a longer period. And for thousands of years, our understanding of planet system are based on our understanding of our own solar system. But how about the planets orbiting the stars are other than our sun? So in 1995, the first exoplanet discovered. It's a planet with a Jupiter mass. It's a Jupiter mass planet with orbital period only several days. We call it a hot Jupiters. Everyone was shocked. Everyone doesn't include me. I was still an elementary school student in the remote part of China. So everyone else was shocked. We don't have anything like this in our solar system. To form a planet, you need to form a core first. Once the core reaches the 10 Earth mass core, it will trigger a runaway gas accretion, become a bigger planet like Jupiter. But again, we don't have anything within this area, so the theorists suggest we should start from the further away and form a core further away, further away like here, and trigger a gas accretion to form a Jupiter, like our Jupiter first, and then migrate inward all the way to their current location. But if this process violent or quiescent is highly controversial, thousands of people are writing to debate this process. So, and then there is a new population of planets detected, which is called super Earth. It has planet mass between 1 Earth mass and 15 Earth mass. It's a Neptune mass. We don't have anything like this in our solar system again, but half of stars in our galaxy have planets like this. This is the most common type of planets in our galaxy. So again, because we don't have this kind of planets, theorists suggest they should form from here again and then migrate inward. And it's still unknown if this process, if there is some violent process involved in this migration process. And now, based on our study, we found most of hot Jupiters are either oscillated or have a large obliquity. It means its orbital orientation is totally different from the stellar orientation. But for this population, most of stars are in multiple planet system, and they have a very small mutual inclination, and they all orbit in the same direction compared to their sun's rotation. So this suggests that this part is dynamically hot. So we think they should form violently, and this part is dynamically cool, and they should form quiescently. If I considered myself as an observer, I'm totally happy to provide evidence to distinguish this formation series. But if I considered myself as a theorist, I'm not happy about this picture. Why this region is dynamically cool, but this region is dynamically hot? Why these two migration processes are totally different? One is more calm and one is more violent. And as you can see, this process, our current understanding are highly biased to the understanding of our own solar system. Maybe our own solar system is not the default mode of the planet formation, because most of stars in our galaxy have this kind of planets. The planet can be formed here. So recently we produced a new model to explanation of this picture, the dynamic cool planet can trigger the gas accretion in situ. So if you can get the mass increase, the planet, the mutual inclination, the mutual here radiance between the planets will decrease, and it will lead the unstable. And unstable will naturally lead a dynamic cool region to a dynamical hot. So I'm very looking forward to working with new students on this topic. And as you can see, there are a lot of opportunities in this field, and all level of students can immediately take the advantage of these opportunities to make their own contributions, because this field is so new and so exciting.